Welcome back once again. And in this module, we talk about implementing full adder logic using 8:1 marks. So to begin with, here is a truth table of full adder logic or full adder implementation. As we see full adder, there are three inputs A, B, C in starting from 0, 0, 0 to 1, 1, 1 are the 8 possible combination because we have three inputs. So 2 to the power 3 in binary logic, we have 8 input possible combination. And you add A with B and with that you add C in. That results in two outputs for the full adder in the form of sum and the carry. So 0, 0, 0, this is the sum and carry. Similarly, 1, 1, 1, you have sum is 1 and carry is 1. Now, how do we use multiplexer to implement this logic? So to do that, what we can see here, we have to see in the column sum, and we see in the row 1, 2, 4, and 7, the mean terms are labeled as 1. The output here is 1. So these are the mean terms which are true. Other mean terms which are logic 0, they are false. Similarly, for the carry column, mean term in the row third, 5, 6, 7 are marked as 1. This is the output is equal to 1. Others are 0. So what we do here, we use the multiplexer 8:1. You have 8 data input lines from 0 to 7. You have 3 select lines from S2 to S0. S2 being the most significant bit, and one signal output, that is the sum. And we map the three inputs of full adder A, B, C in to the select lines of these multiplexers. And then we come back to this column and see that the data input 1, 2, 4, and 7, for which the mean terms are marked here. You see here, they are connected to the VCC by this brown color. Data input lines 1, 2, 4, and 7 are tied to be VCC, that is logic 1. Now, the other mean terms which are 0, that is 0, 3, 5, and 6. So here you see the row 0, 3, 5, and 6. The mean terms are 0. So logic 0, they have to be tied to the ground, that is logic 0. So this is how we implemented one of the output, that is sum of the full adder. So when you apply a specific combination of the inputs from 0, 0, 0, 0, 0, 1, 0, 1, 0 up to final 1, 1, 1, based on these input logic combination, one of the logic lines, the data lines, gets connected to the output, and only the mean terms for which the output is 1, they are sum is equal to 1. For others, the data lines are connected to the 0, therefore sum will be 0. Similarly, what you do here, you get another 8:1 marks. Here the output is carry. Select lines are same. Input lines are mapped to the select lines. However, we look at the carry column. Here we see that number 3, row 3, 5, 6, 7, mean terms are true or marked as 1. Only those rows are tied to be logic 1. So 0, the number 3 data input lines here, 5, 6, 7 are tied to logic 1, that is VCC. Other data input lines 0, 1, 2, and 4. Here also 0, 1, 2, and 4, for which mean terms are 0, have to be tied to logic 0 or ground. So now based on the combinations of the input A, B, C, these mean terms in the brown or the data lines in the brown gets connected one by one. For the carry is equal to 1. For other combinations, carry is equal to 0. So this is how we implemented the full adder logic using 8:1 mux. So this is the positive logic system. Imagine you have the same truth table of the full adder. Again, you have A, B, C, three inputs. There are total 8 possible combinations from 0, 0, 0 up to 1, 1, 1. You have two columns, sum and carry. But now instead of marking mean terms to be true, we are marking mean terms to be false. That is logic 0. So these logic 0 mean terms are in the row of 0, 3, 5, and 6. Similarly, instead of marking 1 in the column carry, we mark mean terms which are 0. So that is row 0, 1, 2, and row 4. So this we are going to use the multiplexer in a negative logic systems. So what you do here, 8:1 marks these mean terms which are marked 0 for the output sum here, the data lines 0, 3, 5, and 6. 0, 3, 5, and 6 are tied to logic 1, that is VCC. The other 1, 2, 4, 7, these are the remaining one, have to be tied to logic 0, that is ground. So this is just opposite to the previous slide we saw in which we implemented a positive logic. Now here, using a negative logic, we are doing the same function. Similarly, for the carry, row 1, 2, and 0, 1, 2, and the 4 are tied to VCC. 0, 1, 2, and 4 are tied to VCC. The remaining data lines, that is 3, 5, 6, 7. Here, 3, 5, 6, 7, they have to be tied to logic 0. So now you apply any specific combination of the inputs starting from 0, 0, 0 to 1, 1, 1. Corresponding data line gets connected to the output and the carry is equal to 0 when one of the lines 0, 1, 2, or 3 are activated or selected, and those lines are selected based on the inputs you apply here. So hope you found this educational tutorial informative to implement full adder logic using 8:1 marks. Stay tuned for more engaging and informative content like this. Till then, wish you happy learning.